This module is titled Semantic Composition Part 2. In a previous module, we saw that a denotational theory of semantics must proceed by assigning denotations or semantic values to basic expressions of a language. We saw that in the simplest case, namely the case of proper nouns or proper names, these can be taken to be whatever they refer to. Similarly, the semantic value or denotation of a declarative sentence can be taken to be its truth value. So for philosophers like Frege, the reference of a sentence is simply its truth value. We talked about this earlier. We talked about Frege's slingshot argument, where he gave an argument, though he didn't formulate it in detail, that the reference of a sentence, if it has one, has to be its truth value. Even if we are uncomfortable with the idea that sentences have a reference, we can simply use denotation or semantic value as a technical term that such sentences can have in particular circumstances, being agnostic about whether reference is the right property in question. We also noted that a compositional denotational theory of semantics must yield, as a consequence, truth conditions of declarative sentences, and in this we follow a long line of philosophers like Tarski, Davidson, Montague, etc. These truth conditions happen to be statements of the following kind. The declarative sentence S in quotes, those quotes are important, is true in circumstance new if and only if P. Here S is a linguistic expression which, following standard syntactic theory, we take to be a structured hierarchical object, say a syntactic tree, and the right-hand side of the biconditional statement is a description in the meta-language. I'll talk in a second what the term meta-language means, of what we take the truth conditions to be. Note first that it is possible to construct a semantic theory that directly yields statements of the form 1 in a trivial way by adopting a schema that says something like the following. For all alpha, alpha in quotes is true in circumstance new if and only if alpha without quotes. This would yield statements of the following form, following Tarski here. Snow is white in quotes in circumstance new if and only if snow is white. Now, while 3 appears to be trivial at first, it is important to see why it is not entirely trivial. It's trivial, but not entirely trivial. The statement on the left-hand side of the biconditional, the one that appears in quotes, is a statement of the language being analyzed, namely English, and as such is a syntactic object. The statement on the right-hand side, on the other hand, is a description also in English of the conditions that must be satisfied in the circumstance new in question in order for the English statement on the left-hand side to be true. The language whose semantics is being analyzed, the left-hand side, in this case English, is called the object language. The language which is used to describe the truth conditions, in this case also English, the one that appears on the right-hand side is called the meta-language. The fact that statements like 2 are not entirely trivial can be seen by looking at example where the object language and the meta-language are distinct. So suppose our object language is Bangla, where borof shada hoy in quotes means that snow is white. In this case, our counterpart of 3 would be something like the following statement. Borof shada hoy, again in quotes, is true in Bangla in a circumstance new if and only if snow is white. Statements like 4 can be made to follow from a principle like the following. Let us call this principle T star. For all alpha, alpha in quotes is true in circumstance new in language L1 if and only if the translation of alpha, where L1 is the object language and translation of alpha is the translation of alpha in the meta language L2. Such a principle does yield Tarski sentences directly, and the consequences of the principle are not entirely trivial. However, such a principle, like T star, suffers from one major defect. It is not compositional, as was pointed out by many linguists and philosophers, and in particularly by Donald Davidson. Remember that as linguistic semanticists, we are interested in a fundamental property of language, namely its recursive character. Expressions of a natural language are syntactically complex. See the introduction to this course. And furthermore, the meaning of a complex expression is composed of the meanings of its parts. An adequate semantic theory must account for this fact. But a principle like T star takes sentences to be unanalyzed wholes and provides no such account. We must strive to arrive at principles that assign semantic values not only to sentences but also to their component parts. We must, for example, be able to see what contribution is made by the verb phrase is white in the sentence snow is white, as it presumably makes the same contribution to the meaning of the sentence grass is white, even though the two full sentences mean entirely different things. In fact, in our world, the former is true, but the latter is false. Native speakers of a language don't memorize sentences. In fact, they couldn't, for the number is potentially infinite. And yet, they can interpret novel utterances they have never heard before. This is possible only because semantic knowledge includes not only knowledge of the meanings of lexical items, but also the knowledge of how meanings of smaller parts contribute to the meanings of bigger syntactic units. But in order to do so, we must look closely at what the semantic values of the intermediate parts must be. Let's consider, in order to illustrate how such a compositional semantic theory would work, a fragment of English, let's call it F1. We first describe the syntax of this language. To keep our discussion intelligible, let's first look at the syntax of a very simple fragment of a somewhat stylized and stilted variant of English. The syntax of the fragment will be described by means of a phrase structure grammar that uses rewrite rules of the type familiar in syntax courses. Now, knowledge of some rudimentary syntactic theory is presupposed for this course, and so readers who are unfamiliar with the material may wish to look up a syntax textbook or a syntax course, which you can find, you can look up an online syntax course, some module that deals with things like phrase structure rules, transformations, and so on, though we won't worry about transformations very much at this point. Let us assume the following rules. These rules are modeled after a textbook in semantics by Kierkegaard and McConnell-Genet called Meaning and Grammar. So let's look at the syntax of F1. The rules of the syntax of F1 look like the following. S goes to NP-VP, meaning a sentence is made up of a noun phrase and a verb phrase. S goes to neg-S. S goes to conj-S. NP, noun phrase, goes to N sub P. This is for proper nouns. VP can go to V sub I for intransitive verbs. VP can go to V sub T, NP, V sub T for transitive verbs. Neg, it is not the case that conj goes to the words and or. Proper nouns N sub P goes to Hema, Shahrukh, Raj. V sub I goes to sings and dances. V sub T goes to likes and hates. Okay, so we are considering a couple of points need attention. As we mentioned earlier, this is a fragment of a somewhat stylized and stilted variant of English. So in colloquial English, expressions like "it is not the case that" are rarely used, though they are common in logicians or mathematicians' English. The reason for this is a matter of convenience. Given the meaning of negation, and we'll talk a little bit about the meaning of negation, it is easier to provide a compositional semantics for "it is not the case that" than it is for the more idiomatic expressions of negation. In fact, interpreting the more idiomatic expressions of negation in English and most other languages requires techniques which involve either complicating the logical syntax or the semantics of expressions that contain instances of these more normal expressions of negations. In natural languages, that can only be provided later in the course. A second point to note is that conjunction words and or are independent lexical items in English. And in many other languages of the world, this includes, for example, the Indo-Aryan languages spoken in northern and central India, for example. However, these notions are expressed differently in many languages. The Dravidian languages, for example, expression conjunction and disjunction or by using particle suffixes on each constituent that's being conjuncted. And these require a different syntax and a slightly different mechanism for the way the syntax is mapped to the semantics. So these are just some of the things that you need to keep in mind in order to make sense of this fragment of English that we are describing. The syntax fragment for F1 given above generates hierarchical syntactic structures, which can be represented either by trees or by labeled brackets or a variety of other representations. For example, derivational sequences that some of you may be familiar from some syntax work, for example, Chomsky's famous book, A Logical Structure of Linguistic Theory, and so on. The fragment presented above is relatively rudimentary. It's very simple. You have 3 proper names, you have 2 intransitive verbs, you have 2 transitive verbs, and a bunch of logical words, and so on. Nevertheless, it is complex enough to generate an infinite number of sentences. This is because of recursive rules that can create sentences within sentences. So, for example, Hema dances, or Shahrukh hates Raj. It is not the case that Hema dances or Shahrukh hates Raj. It is not the case that Hema dances or Shahrukh hates Raj and Raj sings, and so on. It is also complex enough to generate sentences that are potentially ambiguous. So look at the sentence 5. It is not the case that Hema dances or Shahrukh hates Raj. This sentence corresponds to 2 possible syntactic structures that you see in 6 and 7. In 6, it is not the case that combines first with Hema. The 2 together form a constituent, which then conjoins by means of another sentence, Shahrukh hates Raj, and the conjunction word or. Another possible structure is one where Hema dances or Shahrukh hates Raj are 2 sentences conjoined by the word or to form a unit that's a sentence, to which it is not the case that then applies, and you get a full sentence. So in tree notation, these can be represented as follows. Here's what you see. The 2 possible trees for these 2 sentences look like what you see on the figure right now. With this basic syntax of F1 in mind, let us see how the semantics would proceed. The semantics. Now we describe the semantics of this fragment of English, F1. We have seen that semantics of proper nouns can be taken to be things that they refer to. In our fragment F1, these are the proper names Hema, Shahrukh, and Raj. In any given circumstance, they refer to the persons in question, and so their semantic value is just the person being referred to. We saw that it is reasonable to take the semantic value of declarative sentences to be their truth values. Since the same sentence can be true or false depending on the circumstances, its truth value is true or false relative to a circumstance. In the denotation we use below, we use 1 in quotes for the truth value true and 0 for the truth value false. As noted before, we also need to reflect on the possible semantic values of the component parts of the sentences. In our case, verb phrases, intransitive, and transitive verbs. We use the notation square brackets with the superscript nu to indicate semantic values. Okay? So every time you see that particular symbol with something inside it, you should read that to mean denotation of a linguistic expression in the circumstance nu that's being described. So the semantic value or denotation of Hema in nu is Hema the person. The semantic value of Shahrukh with respect to nu is Shahrukh the person. The semantic value or denotation of Raj with respect to nu is Raj the person. If S is a sentence, the semantic value of S with respect to nu is 1 or 0, depending on whether S is true or false in the circumstance we are talking about. Okay? So these are basic things we have already argued for. The denotations of proper nouns are objects, persons, and so on. The denotation of sentences are truth values. What denotations do we assign the other constituents? First, let us look at verb phrases and intransitive verbs. We have seen that proper names name things. What about expressions like sings and dances? These expressions clearly don't name or refer to things, nor are they expressions that can be true or false. However, the semantic contribution they make is to apply to objects to make statements that are true or false. In philosophy and logic, expressions like these are called predicates. Predicates divide up the objects in a universe into those that apply to it truthfully and those that don't. A thorough discussion of predication can be found in the work of many philosophers. The particular one that we will refer to is the philosopher Gareth Evans, whose work is discussed in one of the textbooks that are listed in the references. This is Larson and Segal, 1995. We will summarize Evans's points here following the discussion in Larson and Segal, pages 121 through 140. Readers of this module are advised to consult these works if they're interested in more details. The first point made by Evans is that predicates apply to objects rather than stuff related to objects. Thus, the predicate dances in the sentence Hema dances can only be true if Hema dances rather than some part of Hema being involved in something like a dancing activity. To see the point, imagine a species different from us using a communication system where the expression Hema dances, in quotes, was interpreted to mean that there is some dancing involved where some part of Hema, call it some Hema stuff or Hema part, is involved. Such a communication system is perfectly imaginable. In fact, it has been argued that there are some symbolic communication systems used by many apes that look superficially like very simple human languages. In fact, probably works something like what we just described. It is just that human language is not like that. Predicates apply to objects. They care about the boundaries of objects, among other things. There are two fundamental properties that predicate expressions have that make them different from proper nouns. The first one is what Evans and Larson and Segal call the association with general conditions of application. Conditions that are indifferent to the number of objects they apply to. The word dances, for example, applies to many individuals, all the creatures who dance. The verb phrase is a moon of Venus applies to no object because the planet Venus has no moons. Whereas the VP is a moon of the Earth applies to just one object in our universe. This is to be contrasted with proper names, which are associated with singular conditions of application. That is, they are associated with one and only one object. This is in fact guaranteed in our semantics when we say that the semantic value of a proper name is an object. The second property that distinguishes predicates from proper names is that they are associated with object-independent conditions. Predicates are not only indifferent to the number of objects they apply to, they are also indifferent to their identity. This means, for example, that though the predicate dances applies truthfully to certain individuals, namely those that dance in the real world, things could have been different so that it applied to other individuals without, in some sense, changing the meaning. This makes them different from proper names, which are associated with object-dependent conditions. For example, the fact that our use of a proper name like Hema is tied to a specific individual. Now, what do these considerations about the nature of predication tell us about the semantics of verb phrases and intransitive verbs? Some versions of semantic theory take the predication relation to be basic and develop a recursive semantics accordingly. So, for example, Larson and Segal, the textbook I just mentioned, do exactly that. We take a slightly different route and follow a much more widespread practice and model the semantic value of predicates as sets which are dependent on circumstances. This is what you find in some of the other references cited below. So you can look up Kierkegaard, McConnell, Genet, 2000, Hyman Kratzer, 1998. Basically, this is what we say. The semantic value of the English verb sings in the circumstance nu is the set of all those things that sing in nu. Similarly, dances, the semantic value in nu is the set of those things which dance in nu. Note that our choice of sets as semantic values of predicates preserves the basic insights of Evans. Association with general conditions of application is guaranteed because sets can have any number of members, 0, 1, or many. And association with object-independent conditions is guaranteed because the semantic value of predicate is taken to be a set whose value can vary with the circumstance nu. Evans's first point about predicates applying to objects rather than just arbitrary object stuff will also be guaranteed once we see our semantic rules. So for this, just wait for a little bit, we'll come to this point. Transitive verbs. Well, we can simply generalize the semantic values we argued for in the case of verb phrases and intransitive verbs to transitive verbs, taking them to be relations. So we have the semantic value of likes with respect to nu is the set of ordered pairs x, y such that x likes y in nu. Similarly for hates. Negation and conjunction. Finally, we follow standard practice in logic to provide our semantic values for negation and the two conjunction words. Negation reverses the truth value of a statement it applies to. It makes true sentences false and false sentences true. The conjunction and applied to two sentences is true if and only if both sentences are true, or applied to two sentences is true if and only if at least one of the two sentences is true. The best way to state this is in a recursive semantics to assume that the semantic value of negation is a function from uppercase T to uppercase T, where uppercase T is the set of truth values 1 and 0, and the semantic value of the conjunction words are functions from the Cartesian product of T and T to T. So this is what the semantic values of it is not the case that and or localize. Semantic rules. Now let's give the semantic rules. We say NP-VP, if S dominates NP-VP, with respect to a circumstance new, it gets the truth value true if and only if the semantic value of NP is in the semantics value of the VP. We call this the S rule. S1 conj S2 gets the semantic value, the function conj, denoted by conj, applied to the ordered pair whose first member is the semantic value of S1, whose second member is the semantic value of S2. We call this the conj rule. The semantic value of neg S is the semantic value of neg applied to the semantic value of S. We call this the neg rule. The semantic value of VT and P is the set of all x's such that the ordered pair whose first member is x and the second member is the semantic value of the NP is in the semantic value of the VT. All of these, remember, are relativized to the circumstance new. We call this the VP rule. And a final rule, basically, it says if A is a category and alpha is a lexical category or a lexical entry, the delta equals a structure where alpha directly dominates alpha and nothing else. Then the semantic value of delta is just the semantic value of alpha. We call this the lexical entry or LI rule. Note first that the S rule guarantees Evans's observation that predicates apply to whole objects rather than simply stuff pertaining to them. So if we lived in a universe in which disembodied Shah Rukh parts could dance, those parts would be members with the semantic value of dances, but Shah Rukh himself might not. In such a circumstance, Shah Rukh dances would be predicted to be false, since Shah Rukh is not a member of the semantic value of dances. This is a consequence of the S rule. To see briefly how the rules work, I go through one example that you can see where I take an ambiguous string and apply the rules, and you see the result that you get. Now, once we have done all of this, we can now define notions like entailment, logical equivalence, being a tautology and a contradiction, given our semantic rules. Basically, we say that a sentence which is analyzed as a syntactic tree, if you have a sentence S analyzed as a syntactic tree delta, it entails another S2 analyzed as a syntactic tree delta 2 if and only if every circumstance in which delta 1 gets the value 1, delta 2 also gets the value true. They are logically equivalent if both delta 1 and delta 2 get the same value in all circumstances, either both true or both false. A sentence S1 analyzed as delta 1 is a tautology if and only if it is true in every circumstance. A sentence S1 analyzed as delta 2 is a contradiction if and only if it gets the value 0 in all circumstances. So once we have this, we basically can think of notions like, remember we started by noting that a semantic theory must be able to support, must be able to say something about the basic semantic relationships that we want to explain. Right? One of the semantic relationships we talked about is the notion of semantic entailment. And so, whenever we give semantic rules, we must be able to define what it means for a particular syntactic structure in a particular circumstance to entail something else, and so on. And this kind of a semantic theory that we saw in this module is able to do exactly